Welcome back. In today's class, we are going to proceed with our topics in further mathematics, logarithmic differentiation. Don't forget that in our previous class, we learned that we make use of logarithmic differentiation when we are differentiating a function, whereas we have more than two functions on the numerator or the denominator. Do you understand? Yeah, we are still at the introductory part. But before that, I want us to take note of something. You know, when we have ln x is also the same thing as the log of x to base e. Do you understand? So this is expressed as this. It's very, very important that you know that. Okay, and also I want us to talk about some important laws that we make use in logarithmic differentiation. Those are the law of logarithm. You understand? So, for example, if I have the product of a log, this can be written as what? Ln x plus ln y. Please, I want you to note that if I have ln x over y, this can be written as ln x minus ln y. Do you understand? So if I have ln x raised to the power of y, this can be written as what? Y ln x. Please, it is very, very important that you note that. So these are the three fundamental laws that we are going to make use of in this topic, logarithmic differentiation. So I want to try this. Let's say we have ln x, y, z. Now, let's start by learning how to decompose a complex logarithmic function. When I talk about decomposing, that means we are reducing it, you understand? Because, you know, this is one thing about this subtopic, which is logarithmic differentiation. You can be given a complex questions to decompose, to differentiate. So in order to differentiate that function easily, you have to what? Decompose it. You have to reduce it to the simplest form by making use of all these laws. You understand? So let's see a typical example. So we are told to decompose ln x squared sine 2x all over 2x plus 4. Okay? Don't forget that I told you the natural log of a product of two numbers is equals to the sum of the numbers. Is that not it? Sum of the natural log of the numbers, according to this law. Do you understand? And if you look at the numerator of this function, you can see that the sign between x squared and sine 2x is what? A product sign. Do you understand? So for this, I'm going to express it as this. Solution. Oh, sorry. This marker is not. I have ln x squared sine 2x, but the sign between x squared and sine 2x is a product sign. But I also have a division sign between x squared sine 2x and what? 2x plus 4. And if I have a natural log of a quotient, what will happen? That will be the difference between the natural logs. Is that not it? The natural log of a quotient is the difference between the log. Are you getting it? So you can see that this is the quotient sign. Division sign is here. So for this, I'm going to have difference, which is minus ln 2x plus 4. Please, do you understand how I got this? According to this law, the natural log of a quotient is the difference between the natural logs. So for this, this is a quotient. X squared sine 2x is 2x plus 4 is dividing x squared sine 2x. So I express this using the second law that I have here. I express it as this. Now, I can still further decompose this function because I have a product sign between x squared and sine 2x. Do you understand? So, and I told you that the natural log of a product is equals to the sum of the natural log according to the first law. Is that not it? So for this, I'm going to have the ln x squared plus ln sine 2x minus ln 2x plus 4. Do you understand how I got this? Can we still reduce this function further or not? Yeah, we can still reduce it. I can rewrite this x squared as this. Ln x raised to the power of 2 plus ln sine 2x minus ln 2x plus 4. So you've seen that I've already reduced the function. So it is very easy to differentiate right now. You understand? Don't worry. As we progress in this topic, I'm going to show you how to differentiate using the logarithmic function. Though we have some work example back then in our previous class, but don't worry if you have not watched that video, you can proceed back to watch it. You understand? So, as we progress, I'm going to teach you more on this topic. So let us proceed. Now, according to the third law that we have here, the natural log of the number raised to the power is equal to the product of that power and the log. Is that not it? So I'm going to have ln x squared can be written as 2 ln x, let me just put it, plus ln sine 2x minus ln 2x plus 4. So this has been reduced. You understand? So this is the correct answer. So let's try another question, okay? Decompose ln x squared sine squared pi x all over the cube root of x squared plus 2. To solve this question, you can see that the sign between the numerator and the denominator is what? A division sign, abi? So this is the quotient. And I told you that the natural log of the quotient is the difference between the natural log. Is that not it? So for this, I'm going to have the natural log of x squared sine square pi x according to this law. Are you getting it? According to this law, if I have the natural log of a number that is dividing itself, I'm going to take it natural log minus the other natural log. Is that not it? The natural log of the numerator minus the natural log of the denominator. So that is what I did here. The natural log of the numerator, which is x squared sine squared pi x, minus the natural log of the denominator. That is what? The cube root of x squared plus 2. Okay, so I've not done anything. If you pay attention, you're going to understand it. I'm very sure you understand. So just open your heart and learn. Now let's proceed. You can see that the sign between x squared and sine squared pi x is what? A product sign. And I told you that the natural log of product of x and y is what? The natural log of x plus the natural log of y. That is, the product of a log is the sum of the logs. You understand? That is just the basic laws of logarithm that you're supposed to understand. So let's proceed. For this, I'm going to have the natural log of x squared plus the natural log of sine squared pi x minus the natural log of, okay, don't forget that if I have the cube root of x is equal to what? X raised to the power of what? 3. Oh, sorry. X raised to the power of 1 over 3. You understand? So if I have, let's say I have the fourth root of x, this can be written as what? X raised to the power of what? 1 over 4. Do you understand? So that is a very, very simple. We are still going to make use of the approach here. So for this, I'm going to have ln x squared plus 2 raised to the power of 1 over 3. Do you understand how I got it? So let's proceed. Now, for your basic trigonometry, if you have sine square x can be written as what? Sine x raised to the power of 2. Do you understand? And if you have sine cube x, it can be written as what? Sine x raised to the power of 3. You understand? So apparently, if you have cos, this can be written as what? Cos x raised to the power of 5. Do you understand? So I'm going to apply it here. Let's proceed. For this, I'm going to have ln x squared plus ln sine pi x raised to the power of 2. Do you understand? Just like what I expressed here. Okay? So let us proceed. Minus ln x squared plus 2 raised to the power of 1 over 3. Okay, we have gotten to this point. Don't forget, from the third law of logarithm that we have here, the natural log of x to the power of y is the product of y and the log. The natural log of a power, the natural log of a number to a power is the product of that number, is the product of the power and the log. So for this, okay, let me rewrite. X squared can be ln x raised to the power of 2 can be written as what? Ln x raised to the power of 2. Do you understand? Please, I want to master this. Ln x raised to the power of 2 is equal to what? Ln x raised to the power of 2. So for this, I can write this as this. You understand? So I'm going to have ln x x raised to the power of 2. I don't want to rewrite all this. That's the reason why I just skip. I just explained how I got this in this place. You understand? So let us proceed. Now, according to the third law, we are going to have something like 2 ln x plus, now I have the power of 2 here also, so I'm going to have 2 ln sine pi x minus, I have a fraction of 3, 1/3 here. I'm going to have 1/3 ln x squared plus 2. So I have decomposed this function. Now let me ask you, between this and this, which one is easy to differentiate? Yeah, this is easy to differentiate because you have reduced it to the lowest form. You have reduced the function to its lowest form. So it is very easy to differentiate at this point. So let's have another work example. Okay, let's proceed to question number 3. We are taught to decompose ln sine square x cos square x all over tan square x. We proceed as okay, let's try this. Now I want you to try this. Pause this video, then when you are done, play the video to check your answer. Maybe you are correct. You are still going to use the same step. Don't forget that the sign between the numerator and the denominator is a quotient sign. So, and I told you that the natural log of a quotient is equal to the difference of the natural log. Is that not it? So for this, I'm going to have the natural log of sine square x cos square x minus the natural log of the denominator, which is what? Tan square x. Do you understand? Okay, let's proceed. And the natural log of product of x and y is equal to the what? Natural log of x plus the natural log of y. So the natural log of the product of sine square x and cos square x is what? The natural log of sine square x plus the natural log of cos square x minus the natural log of tan square x. So we have gotten to this point. Don't forget that we learned that sine square x can be written as what? Sine x raised to the power of 2. So for this, I'm going to have ln sine x raised to the power of 2 plus ln cos x raised to the power of 2 minus ln tan x raised to the power of 2. Do you understand? So for this, I can write this as, according to the third law that we learned, the natural log of x to the power of y is equal to what? Y ln x. That is the power we multiply the log. So for this, I'm going to have 2 ln sine x plus 2 ln cos x minus 2 ln tan x. So is there any further, can we further reduce this function? If there is none, then we can differentiate this function at this point. You understand? So it is easy to differentiate right now compared to when we have it in a complex form. So that is the aim of decomposition. So we are going to proceed to how to differentiate a logarithmic function.